So 11.5 is about alternating series. What we mean by this. A series of this form where this Bn is greater than 0. So it's alternating because with changing n, you get a plus and minus in front of B. And we have to check two things. So this series is convergent if Bn plus 1 is less than Bn. This is true for all n. So it may not be from n equal 1. Some finite numbers. This should be true for all n starting from say 1, 2, 3 or any. But after a finite number, this should always be true. Then the second condition is the limit so these two conditions should be true for this alternating series to be convergent. Let's do some examples. Number 7. So this is an alternating series where Bn is and it is easy to see that Bn is always positive because this is always positive and it's from 1 to infinity. And this is also always positive because 3 is greater than 1. So now we check these two things. And you can check it in any order. You don't have to follow this order. So for example, if we first check the limit, this limit. You can either use L'Hopital rule or you can factor out n. And this is same as so then goes to infinity. This goes to 0. This goes to 0. So this condition is then not satisfied for here. So this means that the given series is divergent. Because this limit and going to infinity bn is not equal to 0. Let's do next problem 11. This is cube. So here bn is you can rewrite it in this form. You can cancel it out. So bn becomes so the limit is 0. Right. So this term goes to 0 and this goes to infinity, which is why this is 0. So the first condition is true. So this condition is true here. Now we have to check the other condition. Bn plus 1 is less than bn. And how do we check that? Let just replace x or replace n by x. So we replace n by x. such that f of n is. Why we do that? Because if f derivative x is less than 0, this means f is decreasing function. And that would mean, or first write with f. So that would mean f of n plus 1 is less than f of n. This means then bn plus 1 is less than b. So if f derivative x is less than 0, f is decreasing function, means fn plus 1 less than f of n. That would mean bn plus 1 is less than b. So this is what we have to check for this function. Let's calculate f derivative. Quotient rule. So which is x negative x cube plus 8x. This term gives you 8x, 4 times 2x. And then you have 2x times x cube. So it should be x4, not cube. So 2x times x cube gives 2x4 minus 3x4. So you get negative x4 plus 8x. And this will be negative. So this will be true if x is greater than 2. So when x is greater than 2, because when x is 2, you have 16 and 16. So 16 minus 16 is 0. So x should be greater than 2. So it means starting n equal 3, this condition is true. So that's what I wrote after some finite number. So in the given problem, we see here, so this is true, starting n equals 3. Starting n equals 3, this condition holds. So therefore we conclude that this is convergent. You can write it anywhere. Let's do one more problem. Number 17. So here Bn is so it's easy to see that the limit right, because as n goes to infinity, this term goes to 0 and sine 0 is 0. So if you observe sine, and this condition is true because sine 0 is 0. Now in order to check Bn plus 1 is less than Bn, so if you look here, n equals 1 is pi, n equals 2 is pi over 2. So for this part is not true because pi over 2 is 1. However, starting from n equals 3, or starting after n equals 2, n equals 3 would be pi over 3. So if this point is 1, pi over 3 lies here, then pi over 4. So this is n equals 4, n equals 3. So pi over 4 lies here. Then pi over 5 will lie here, so on. So this is true starting n equals 2. Because n equals 2 is the maximum pi over 2. And when n is 3, pi over 3 here, and pi over 4. And then as n goes to infinity, this becomes 0. So as n goes to infinity, we'll have 0. So therefore, we conclude that this is convergent. Now let's do one problem with error bounds. We have to show that the series is convergent, and how many terms of the series do we need to add in order to find the sum to the integrated accuracy. So we have to show that error is bounded by 0.5, the same as 10 to the negative 5 or 5 times. So we have to show that this is convergent, and then we have to find n such that the error in the sum is bounded by this. So let's first show convergence. To show convergent, we use alternating series test. So Bn is clearly limit is 0. As n goes to infinity, get 1 over infinity is 0. And Bn plus 1 is clearly less than 1 over. So Bn plus 1 is less than B. Because this has a bigger denominator. N is greater than equal to 1. So if n is 1, this is 2. N is 2, this is 3. So 2 to the 6 is less than 3 to the 6. So because the denominator is greater here, this 1 over that is less. So both conditions are true. Therefore, convergent. Now what this means for error, to show that error is less than first you have to remember that error is bounded by Bn plus 1. Now the number of terms we need, we have to find the largest n for which this is true. Or rather guess or find this n for which this holds. Then the answer will be n plus 1 terms. So if we can guess or find the largest n for which this condition is true, then the answer will be n plus 1 terms. So what this means is we have to find, so Bn plus 1 should be less than 5. This means we have to find n such that now you can guess some n values and check that say for n equals 3 bn plus 1 we get is so this does not work. That should be the smallest. I'm confusing some things. Right, so this is greater than, so this does not work. Now let's see. Let's see what happens when n is 4. So B5. So B5 turns out to be so B5 means I think I've written this in inequality wrong. It should be other way around. That's why I'm also getting confused here. Sorry for the confusion. So this should be B. Right. So I wrote this the other way around, which is why I was getting confused. All right. So it means we have to now find so now if you look here, this is true. However, this is 10 to the minus 4. So we should check. True, but we should check n equals 4 also, because this is of the order -4, this is -5. So now when n is 4, you get B5 as this. This is true. So both are true, but we're looking for the largest n for which this is true. So here 6.4 10 to the -5 is greater than 5 times 10 to the -5. So it means n should be 4 and terms should be 5. And you can check what happens if you go n equals 5. So you get B6, which is equal to now this is less than so for this false. Because we need Bn plus 1 to be greater than 5 times 10 to the -5. So this is false for this B6. And it is true for all n's up till n equal 4, that is up till B5. So we are looking for the largest n for which this is true. And the largest n we conclude here is n equals 4, which gives B as 5. So n plus 1 is 5. So the answer is therefore 5 times. So we need, you can write it anywhere, 5 times. Your answer will be n plus 1 times. That's all for this.